Hi, I'm Doug Black. I'm editor-in-chief of Inside HPC. And today we have with us Ryan Quick. He is a principal and co-founder at Providentia Worldwide, which is a technology consultancy. Ryan has extensive expertise in HPC and big data technology strategies. And the basis of this interview really came about last month when Ryan was part of our Hyperion series of interviews, the Hyperion HPC Steering Committee. And Dan Olds interviewed him, and the topic came up of putting together HPC clusters, HPC cluster strategies, and the difficulties of doing that, even within a single vendor's product line, which I think was a little bit eye-opening for me, and kind of got at what appears to be a pretty significant issue for on the user side for HPC strategists trying to put together solutions. So, Ryan, why don't you take it from there? Just sort of establish the premise of our discussion.
Yeah, a lot of times, uh, we hide some of the nuts and bolts of buying clusters, because a lot of what gets the biggest focus is the end result. After you go through these large purchases, which gets a lot of coverage, you sort of a year and a half into the RFP phase, and what comes out is everything gets delivered, and then you kind of pick up the story. But for smaller clusters, the ones that end up in the enterprise, there's a lot of a lot of back and forth, and what gets bought is more like a bill of materials, and for hybrid clusters especially, or clusters with kind of off the shelf parts. There's this phase where you're trying to put together a package, even within the bounds of what a single vendor might offer, where it's the responsibility of the systems engineer or architects, within the enterprise, um, that that can be daunting, because you're still trying to build a unicorn, even within your own enterprise. These systems are never truly off the shelf. You're building them with off the shelf components, but they've still never been assembled this way before. And a lot of people don't realize that, especially inside the HPC world, we get complacent with one another, because, yeah, everybody's building together a cluster, and yeah, that's what we're here to talk about when we go to these big shows. Everybody's got their cluster, and everybody's running InfiniBand, or everybody's running 100 gig Ethernet. But we tend to forget that nobody outside of our world does that. And so when you're sitting down with the vendor, you're still sitting down buying something that very few people really do, and that's true even for the vendor. And so when you're putting together a spec and a bill of materials and saying, okay, I want 8 racks that are interconnected this way, with a set of switches to do this, and I want this kind of storage, and I want they're going to interconnect with my data center. Now you're starting to get into something that hasn't ever been built before, especially when it comes to your data center, right? You've got components that have been around. um, you know your enterprise starts to differentiate as soon as you get to the top of the rack. um, and that's where the components start to get a little bit strange. And so it can get to be a little bit difficult. And I think that's what you alluded to in the Hyperion series that we did. That happens a lot, and you'll start to say, okay, well, okay, I want this cluster, but in my network, I've got to communicate with 6 Oracle databases over here, and I've got 2 instances of Teradata that they've got to talk to over here, and I've got a Cassandra instance over here that it's got to talk to, and oh, by the way, I'm going to export all that to flat files. And when you start to talk about that to the vendor, they're like, well, we've never actually had a HPC cluster that wanted to export anything before. You sure you don't want to just build a weather system? Like, well, weather's great, but we don't do weather here.
Yeah,
And so,
yeah.
you're like, well, we've never qualified Oracle drivers on this before. That's the kind of conversations that you start to have. And that's kind of what I was, sort of alluding to in that
But
conversation. And that's where it starts to get a little weird.
am I right in saying too, though, that there seems to be sort of a broken links within vendors and vendors' sort of product categories?
Oh, yeah.
Uh, yeah, in the HPC class of technologies, where it's hard to get them to even work together or to provide from a vendor an integrated solution in and of them itself.
Oh yeah, for sure. You'll be saying something like, one of them I built, and I actually mentioned that in that particular interview. We had a system where we were trying to connect an object store. We wanted to extend an object store into the cluster, and we at the same time we were extending out the storage array, and we wanted to put them. We wanted to put them together and say, we wanted this same functionality to be in the same place, because we knew we needed the storage to do both. Um, and the vendor provided both technologies, and but the business units that sold both pieces were different from one another. So we could buy the object store from the hyperscale business, the and we could buy the cluster storage from the HPC business, and even though they were literally the same components, like if you would go to the back and you would look at them, the cable was the same part number to connect, and we could show them that. But if you tried to buy the SKU for the object store from the hyperscale, or from the HPC guys, they would be like, "Oh, we can't sell that piece to you," and vice versa. So it took this. We had this. It was great. We had this big conference where we had to force the vendor to get in the same room. But both, we had to have this, like, had our account reps force the two different sides to get into, bring their other their sales guys from both sides to the same room. So it was like, four of us from the account, and then like 8 different sales reps all in the same room, just so we could have a conversation about, okay, how can we buy these things, and you guys adjudicate amongst yourselves how we're going to cable it together. We know it can be done, right? It's not rocket science. You guys sell the same parts, but you have no facility on the support side, on the cabling side, on the design side, to be able to support something that's put together this way. We want to pay for it. We're not asking you guys to do something crazy here, but other than walk across the aisle from each other and shake each other's hand for a few minutes. But yeah, it can be very difficult. And for me, it felt very, very strange, because I was lucky enough to be a tier one customer, and at the same time, I felt like, what if I was a small guy,
Right.
or
That was my
or a,
next question. Yeah.
or a hospital or somebody like that, who doesn't realize that you can use your buying power as a client to sort of pull the vendor along,
Mm.
that's relying on the vendor to tell you what to do in most of these cases, and doesn't realize that you have the authority and the power as a customer to be able to do those kinds of things. You would never know that you could build these kinds of things. It's interesting and sad at the same time.
Yeah, you kind of have to pull together a cluster of people to put together this cluster that you particularly want. And it sounds as though these these can be very unique, very custom solutions. There's a limited economies of scale for the vendor to have a solution in place. What, in terms of practical responses to this problem or solutions, what are your thoughts in that area, other than hiring a technology consultant like Providentia? But are there other technologies or some of these consortia working on platforms and standards that are addressing this problem and maybe helping it?
I don't know that a lot of people see it as a problem, and I don't even know that I would really characterize it as a problem per se, because I mean that sort of makes it sound like this is a, this is like a mountain to be climbed. It's more like it's a observation that I've noticed that's occasionally has a unfortunate result out there every now and then. What I would say though is that there are standards that are out there that are kind of coming together to meet in the middle, and that eventually they will share from one another. And I think you're already seeing that. A decade ago, we had sort of the big data revolution, um, and that was led, primarily by the hyperscale guys, with sort of like the Hadoops of the world and whatnot. That's come back around in the name of AI, but this time AI and HPC are much closer to one another, as you see that. And so much so that there's this sort of natural blending through the GPU. And whether or not the HPC and the AI guys want to call each other partners, NVIDIA and AMD certainly see it. You know what I mean? Um, right. They see the convergence, and they're absolutely there to capitalize on that. Um, and I think you'll see more of that moving forward. And I've already mentioned, like this, the storage case was one that I told you, and I think you'll see, there's certain technologies that are going to be out there capitalizing on that first. Obviously, interconnects was there early. The GPUs will be there, storage will be there. But do I think it'll happen intentionally? No. I think it'll. I don't think there's some grand architect of the of the technical universe that's aiming to make that happen. No, but I think that there will be standards that emerge that are conveniently accessible by different parts of advanced computing, and they'll make themselves accessible and usable um, by lots of different folks, and then they'll naturally come together, and then people will start going, "Hey, I saw you at this other conference," and
Yeah,
things will go that way.
sort of a good if unintended consequence of some of those efforts. Yeah.
Yeah.
What about HPC in the cloud? Does that help in a way? It's obviously pre-tested, pre-integrated. It's an all-in-one platform. Is that a response to given appropriate workload scenarios?
It is, though. I think that HPC in the cloud is often more of a misnomer than anything else. It's just workload in the cloud. I think because I would I would ask the folks to try and point at what is HPC versus what is just technical workload versus what is just heavy workload versus what is just workload, and try and draw me a hard line and tell me what's the difference.
Yeah.
Ask the computer to try and identify which one is which to you, and it's just going to go, I don't know. it's just, to me, it's just math. It's so, but math in containers is just math in containers. But
Mhm.
but
Yeah.
but I do think people and certainly technical managers have to categorize and whatnot, but I think over time workload and workload management will certainly share um, the same need to categorize better. I'm hoping personally that the orchestration tools that we're starting to see will start to share, because job scheduling has a really good head start, especially placement tools for distributed workloads that come from the HPC world have a really good head start over some of the more modern ones, like Kubernetes and Mesos and stuff like that. But the Kubernetes and Mesos world have a much more advanced automation understanding than those other tools do, and seeing the two worlds collide will be something really revolutionary. So I'm actually counting on that quite a bit since I use both sets of tools quite a bit, and I'm tired of bridging the gap myself. I'd like to see the development world from Kubernetes come in contact with the parallel programming world from PBS. That would be really nice.
Well, it sounds like it's bound to happen.
Yeah, I think it will
inevitably at some point. Okay, Ryan. Well, great stuff. Great insights. Thanks so much for your time today.
Cool. Thanks a lot, Doug. Appreciate it.
Okay.